I like to refer to Tom Slick as a pioneer of the possible. He thought every idea was worth listening to, and he was just an absolute delight, a true pioneer of the possible. His wildcatter father, Tom Slick, known as King of the Wildcatters, had 3 children, one of whom was Tom Jr., who became a successful oil man in his own right. Tom Slick taught his son to be daring and had taught him that without trying things, one never succeeded. Tom inherited that same spirit, that nothing was impossible and that there was no such thing as failure, and that one simply dealt with an outcome, moved forward, and tried again. After numerous trips to the Himalayas, where he had seen some remarkable feats, the early mission was to study those unusual abilities, those phenomena, and try to document them scientifically to see whether they were the product of the human mind, whether they were a product of wonderful trickery, or something else. It was that search that inspired him to eventually found the Mind Science Foundation in 1958. He wanted to scientifically study the fields of human potential, ESP, psychokinesis.
He's way beyond his times. Although people knew about this unusual phenomena, nobody had the vision to do study about it.
Like most creative people, he never lost that spirit of childlike wonder. The interest in consciousness was always there, and it was just the approach to that topic that has changed over the years. Towards the end of my tenure at the Mind Science Foundation, Francis Crick, Nobel laureate, began to talk openly about consciousness, and it was really a breakthrough because it was the first really major, world-renowned scientist that used that word on his lips.
They defined the goal of what Mind Science Foundation should be aiming more on the study of consciousness. What is really consciousness? Nobody could really explain what it is.
Consciousness was really always what the foundation had been looking at, but had not really called it that, and there was a wonderful shift. It was then that the Mind Science Foundation started funding the efforts of leading scientists from all over the world who were working to solve that great mystery: how the human brain creates the experience of consciousness.
In a very general sense, I think consciousness is just our subjective experience. It's the sensation of the smell of a rose or seeing the color red that I perceive subjectively.
It's really our encounter with the world. It's our emotions when they become conscious, when we become able to talk about them in a coherent way.
So consciousness is the first person experience we have of the world. That's what it is. And the real question, to my mind, is what's happening in the brain and what are the circuits that can cause this feeling of awareness or consciousness?
It's mysterious in the sense that it embodies the capacity to have what was called the inward turning of consciousness and examine one's own mind. But it's also profoundly mysterious in the sense of considering how the ionic transfers and nerves, the electrochemical changes in the brain, the coalition of neurons all possibly doing the same thing, they're discharging at the same rate, somehow contrive that there's an experience.
This amazing mystery, how we move from just electrical activity in our brain and nerve cells talking to each other, to me experiencing myself talking and seeing you and experiencing memories and emotions, how the two are related to other is really a major secret that we still don't have a solution. You look at this issue, how to explain just the sense of color red with electrical activity flowing in the brain, looks like such an amazing problem that some philosophers say it's impossible to answer.
For millennia, we've been thinking about consciousness. Philosophers have said many, many things. And now, finally, neuroscientists can actually measure things and test their hypotheses.
Our assumption as neuroscientists is that consciousness is generated by brain processes, and that by studying the brain, we will be able to understand how consciousness is generated. That is, what brain areas are responsible for our experience of consciousness, and what circuits, neuronal circuits and neurons within those areas are responsible for generating that conscious experience.
Yet it clearly has a physical basis. We don't altogether understand the relationship between the physical goings-on in our bodies and our brains which make consciousness possible.
There's no question, there's a very close link between the brain and consciousness. And so we know a lot about this in people, in patients, and in animals. And what people are focusing on now, by and large, on the scientific side, the side that I represent, the research side, is something that Francis Crick, with whom I started this, the guy who discovered with Jim Watson the double helical structure of DNA, we call the neuronal correlates of consciousness. Most of what goes on in your brain is unconscious. Yes. If I had to put a number, I would say 90% plus of the activity in your brain is unconscious, responsible for making you see and breathe and think and remember, all of it unconsciously. And the stuff that you're conscious of is probably only a minority. It's possibly a very small subset of brain states.
So what happens when information becomes conscious? And the global workspace theory suggests that the information that's currently conscious is information that is being broadcast widely throughout the brain.
What we end up with when we hear a single sentence is just a tiny amount of the huge amount of processing that we know goes on in the brain. And that is a general property of consciousness, that the tip of the iceberg frequently, or perhaps always, with mental processes is conscious, and this giant body of the iceberg is submerged under the sea. That seems to be a fundamental feature. And why that should be so is very unclear. We don't know the answer. We have some ideas, but we don't know the answer.
There's huge unconscious processes that are going on that are affecting what comes into consciousness. And high-level processing goes on in the unconscious level. So what I really want to try to understand is what's going on in the neural basis, what's going on in the unconscious. Why are certain things conscious and others not?
And there seems to be competition between various candidates for consciousness. Some thought will come up in your mind, and it will compete against another thought.
Now let's do basic science. If you hear, mom's voice, what part of the brain is responsible for you consciously perceiving your mother's voice? As in contrast, for example, there's also unconscious processing going on. It may well be that parts of your brain respond to your mother's voice without you consciously knowing about it.
What's the difference in neural activity between things that are conscious and unconscious? How do things come up from the unconscious into the conscious, and how are they pushed down?
Now, in the field of vision, for the last couple of decades or so, there's really been a great interest in what visual artists are doing from the point of view of the vision researchers, because it is often the case that an artist will discover a visual illusion or a way to convey some percept on a canvas that maybe a vision researcher hasn't thought of.
One of the main lines of work is to study visual art and visual artists directly, because they are people who have an incredibly deep intuition of the visual system, right? They're able to take a bunch of paint and put it on a piece of canvas that's flat and make it look like a three-dimensional image, like you're looking out the window. So they have this understanding about how the visual system works and can apply these illusions.
It's clear that vision is a construction of the brain, because you don't even need your eyes for vision. So when you go to sleep at night and you're having a dream and your eyes are closed, you have full, rich visual experience without your eyes being involved at all. So what this illustrates is that you have internal activity in your brain that is the basis of vision.
Visual illusions don't represent errors in the way we see things at all. They represent the way the brain actually works.
We are responsible for what we are seeing. It's not just coming out from the outside world. we are generating it in our own mind.
Our normal visual experience is made up of processes that change the way the world actually looks to make it easier for us to interact with it. So studying visual illusions has become an important way to understand how normal vision works.
Just like a video camera, you walk around, you open your eyes, and somehow the visual world is flowing into your eyes, and you are very passively, very conveniently simply videotaping what's happening out there, and that is what you see. This is a complete wrong understanding of what happens when we see something. The truth is that seeing is a very, very creative process in which you are generating images in your mind, and it is very easy to demonstrate that the images you generate belong to you. You are not simply passively copying information coming from the world, but you are taking information in and you are generating out of it images.
So we all construct the reality around us on a first-person, personal level. And that is the essence of our experience. And it's just not true that we're actually trying to see the world the way it is. What we're doing is our brains are constructing a world that we can coexist in, or we can perform and survive in, and it doesn't actually match the physical reality. So the bottom line is that our entire visual experience is in itself a visual illusion. That is the way our brain's actually working. And so when we study the visual system and study the neural correlates of visual perception and how illusions work, we're finding out the actual fabric of the universe for us.
You have about a third of your brain devoted to constructing the illusion of the world out there. And we've come to understand a lot about vision, about how you have a neural division of labor. You have different parts of your brain that care about different aspects of vision, like color and motion and edges. And somehow these all work together to give you this construction of vision. It turns out the same sort of story is emerging with time. You have lots of different parts of your brain that are involved in constructing the illusion of time. One of the challenges the brain has to face is that you have all these different senses and they process information at very different speeds. My visual system processes the information at a certain rate and my auditory system at a different rate and my hands at a different rate. So the information is arriving in different parts of my brain at very different times, and yet it seems synchronized to me. By the time you think the moment now happens, it's already happened a long time ago. Your brain's collected up the information, put it together, and then you have consciousness of what just happened. But it turns out you're living in the past. So it turns out that your motor system can respond very quickly to stimuli, but your conscious brain is always the last guy on the ladder to get any information. Your perceptual life is like a live television show, which is not actually aired live. These television shows are always aired with a little bit of a delay, and that's what your conscious life is like. So, for all you know, this documentary may already be over, and you're just now catching this.
Taking a step back and thinking about consciousness in an evolutionary sense, it seems very likely that consciousness, like the rest of our cognitive abilities, our psychological capacities, has evolved, and there's no reason to think that there's any sharp distinction in evolutionary terms between human cognition and animal cognition.
So do animals have consciousness? It's a tough question to answer, of course. You can't just ask a monkey or a dog or a cat whether they're having the same sort of rich experience that you or I might have.
I think that we need to try to understand how human consciousness has developed from related forms of cognition in animals, and certainly most of us intuitively believe that animals have a number of kinds of consciousness, if not as many as we do.
I certainly think animals are conscious, and how far down the evolutionary tree that goes, it would not be clear, but I think it goes a long way down. You know, you've got to ask the question, how many neurons working in ways that perhaps we don't understand as well as we might, but working together, is it 1,000, is it 100,000, 1 million, or what, required, I mean, in order to produce consciousness?
It's a very interesting issue, as to where in the animal kingdom consciousness comes and how.
I would think that a lot of animals would have a subjective experience. Certainly primates, but even probably all mammals or most mammals would have a subjective experience of the world.
A somewhat higher level, more interesting, psychologically more interesting sense was explored by the psychologist Gordon Gallup, who showed that apes, but not monkeys, are able to recognize themselves in mirrors. So if you put a mirror in a cage with a monkey, it will indefinitely treat its reflection as if it were another animal. It will threaten it and appease it. Whereas if you put a mirror in a cage with an ape, after a few hours of experience, it will come to appreciate that it's looking at itself. It has a kind of self-concept of it's an awareness of itself as the possessor of a body.
The basic issue that the study is getting at is how sophisticated cognitively chimpanzees are versus humans. And I think that there are a lot of studies that have shown that they're really quite sophisticated, and both in the use of tools and the use of language, and they even have cultures.
If you really think about it and you apply the same standard of evidence to consciousness among humans, it's actually very hard to decide whether other people have consciousness. And so it becomes a very tricky problem, not just in studying whether animals have consciousness, but also really in assessing the very fine-grained nature of human consciousness.
Now, we don't know whether there's a magic line that you cross, sort of a Rubicon below which conscience suddenly stops. So we don't know really about birds. They're very complex. They can have, some of the birds can hide. They have thousands of caches where they can hide food. So I would assume birds too. I would assume that most complex animals are conscious. There may be some simple animals like worms, for instance, that may be just all pure reflex, that may be pure zombies.
Most people who have cats and dogs would avow that their cat or dog was conscious, but few would say it's the same kind of consciousness as we have. So how do we get around this issue of animal consciousness? This is particularly important, certainly in many countries such as the US and the UK, where we work on animals in labs, on how much are they sentient, how much are they feeling, where is the Rubicon, where do we draw the line in the animal kingdom, above which, happily, some animals are consciousness, and sadly, the others, fleas possibly, lobsters some might say, are they not conscious? And if they aren't conscious, where is that magical line? When suddenly does a brain become conscious? Because if you look at animal brains, of course they're all different. And even nervous systems, even forget brains as we know them. But the blueprint is still the same. It's a continuum. It's very hard to draw a line and to point to some feature in sophisticated brains that would qualify for consciousness and not in others.
The butterfly. A worm with fruit peel wings crashes to the ground. Flabbily, he gasps and rests beneath his stinking orange peel, staring up at the sky.
Arguably, artists, poets, writers are the real experts on consciousness, aren't they? Artists pay very tremendously close attention to the texture of our experience, and their interest is in somehow managing to find forms of music or patterns of paint or forms of words which will convey their experience to others.
Through the black wood, past the poisoned water, past the mirrored grit on the trail, moon one careful O of the mouth. Sometimes no witnesses.
Music gives you a unique window on the brain. Hit a note on a piano or pluck a string. They're all the different harmonics, and they're presented together. But you hear a unitary pitch at the fundamental frequency of that harmonic series. When we listen to music with strong beat or strong harmonic changes, that music is impressing on our brain its own time structure. And if we dance to the music, we're reinforcing that by moving our limbs in synchrony with the music.
I was recently reading a paper which recruited a group of professional musicians, all of whom could identify pieces of music which gave them shivers down the spine. In this study, the musicians were played pieces of music which gave them shivers down the spine while in the scanner. And these were compared to pieces of music which didn't give them shivers. And it was shown that the pieces which aroused, evoked shivers, activated regions of the brain which are also activated by eating, sex, very basic activities which give us strong basic rewards. So clearly it is the case that music can key into these appetitive, emotional centers in the brain.
It turns out that almost any cross-blending of the senses is possible. So some people will hear words and it will put a taste in their mouth, or they'll see something and it'll make them feel like they're touching it with their fingertips. By studying these different forms of synesthesia, this allows us to understand how the senses normally work, how consciousness is normally constructed by the brain. So when we find music synesthetes, we test them on notes and intervals and timbres of instruments. And what we're able to do this way is collect out in a very detailed fashion exactly what their colors are for these different sounds. And that way, if somebody has, let's say, pitch color synesthesia and chord color synesthesia, we can ask about the relationships between these. Similarly, with instrument timbres, we can ask what is it about the sound that determines the color. The more high frequency energy in the instrument, the brighter the color. And with something lower, they'll tend to experience dimmer colors.
There was a subsequent report of somebody who very much enjoyed music, who used to find Rachmaninoff preludes tremendously exciting, who following a stroke lost his ability to experience those shivers down the spine. Though he could still hear the music, he could still appreciate its technical qualities, but it no longer excited him. And he had brain damage from the stroke in just one of the areas that was identified in the previous experiment as being activated by music which caused shivers down the spine in the professional musicians. I mean, there are certain pieces of music which have tremendously strong emotional effect on us. Well, if we can discover how those pieces of music work on the brain, how they turn the key in the lock of emotion, then we'll be learning something very interesting about the basis of experience in the brain. So there's a kind of developing study of neuroaesthetics, which I think is exciting.
It's really exciting to be a neuroscientist now and to be doing that, because we really are understanding and learning how the world is actually constructed for us.
If we could get to that stage, in other words, take all the entire phenomena that we call conscious phenomena, and all the entire phenomena that we call subconscious phenomena, and find some elegant principle that relate them to brain activity, we will make huge progress. Unfortunately, we are not there yet.
Consciousness can be a real thing that can be studied by very serious scientists and taken legitimately. And so I think that we need to just keep moving in this direction and not be afraid to investigate it, for up-and-coming people in the field.
Consciousness is a natural property of the world, and it should be studied scientifically, partly because we want to help people who have disturbances of consciousness, schizophrenic, autistic, all sorts of people with mental diseases, but mainly because it's such a curious, wonderful feature of the world. We want to understand where does it come from, who has it, who doesn't have it, what are its properties, and how does it come to be inside the world.
I think there's a lot of technology out there. I mean, some people are pessimistic and say, well, we'll never solve it, and why should we even? But if we say that, then yeah, then we never will solve it. But I think we need to remain optimistic and keep funding research in this area. It's not only exciting because it's going to teach us a lot about how the brain works and about consciousness, but also it has very practical applications, and we can help patients.
Studying consciousness, if you want to, if you directly want to say, okay, I want to study consciousness, by and large has been funded by, not by the standard large-scale National Institute of Health and National Science Foundation, but by private foundation or private individual, in particular by the Mind Science. They're the one since 10 or 12 years consistently fund this sort of science.
the major fundamental secrets or mysteries that are still facing us as scientists, as culture, this is the relationship between brain and mind. I consider one of the most amazing and fundamental secrets that still are unexplained.
Do we know what's making us conscious in terms of neural activity? The short answer is no. We have some clues, we made some progress, but the Nobel Prize is still out there.